Hello, everyone. I'm Lee Lilly of the VAW-VRC VUQ Foundation, and welcome to the VAW-VRC VUQ Foundation's Oral History Project. The goal of this project is to capture and preserve significant events and their associated stories from the VAW-VRC VUQ community's illustrious history and make them available to the community and general public. Today, we're going to discuss with our interviewees the creation of the E-2D program. Carefully listen to our guest today describing the E2 program on a path to sundown, and a new program manager realized the folly of that path. He and the other interviewees put together a program that required innovation in creating a two-generation leap in technology, a program that allowed for continuing production while upgrading aircraft systems, tenacity overcoming issues with funding, testing, and integration, as well as institutional bias. In short, these men were the right people in the right place at the right time. It is my honor today to introduce interviewees who were essential in the success of the E-2D. Captain Peter Shepard, known as the father of E-2D, has an extensive background in the Hawkeye community. He had flown the E-2A, the E-2B, the E-2C, and the E-2C ARPS. He served in all the squadron positions and subsequently selected as XO and CO via VAW-116. He held various positions in acquisition, most importantly, his last position as PMA 231. Mr. James Day was a senior fellow and technical director of the Airborne Early Warning Radar business area at Lockheed Martin. He led a team of more than 150 people addressing current, midterm, and longer-term threats for the E-2 Advanced Hawkeye radar system. Jim's engineering expertise was critical in the design development of the APY-9 radar and subsequent improvements. Captain James Clifton began his military career as an E-2B pilot, NFO, an E-2C and a naval flight officer, and deployed with VAW-115. Jim is a naval test pilot graduate and worked as an E-2C project officer, leading to the testing of the Group 1 and Group 2 systems. Subsequently, he held the E-2C class desk, and in his final E-2C2 community job, he was the lead for PMA 231 Advanced Development Team, which included the early design, program planning, and contracting on what ultimately became the E-2D program. Mr. Fred Lee has served in government and industry technical leadership positions. Mr. Lee served the U.S. Navy in several different civil service positions, including Deputy Program Manager for E-2 Advanced Development at PMA 231 and Section Head Airborne Early Warning Radar at the U.S. Naval Research Laboratory. Pete, please talk about your preparation, assuming the leadership of PMA 230, and what were your observations on arriving?
I'm Captain Pete Shepard, retired. I was PMA 231, assigned that job after being the deputy for systems engineering for NavAir for 3 years. When I assumed PMA 231, my first pass down was with the previous PMA, and I was advised that my job in taking over PMA 231 was going to be to shut down the E-2 production line and to execute a budget of $1.7 billion to upgrade Group Zeros and Group Ones to Group Twos. When I looked at that, the budget was laid out that I would have one airplane upgraded in 1993, 2 airplanes upgraded in 1994, and 27 airplanes upgraded in 1995 to a Group 2 configuration. Anybody who's ever been in program management would look at that and say, that is a non-executable program, and it's ripe for everybody else stealing from the program and the program going down in flames. Also, I was not given any research and development budget, so I had no ability to really go forward and do some of the things that were necessary to make a program executable. Also, I was given minimal operational maintenance funds, OM&N funds, and anybody who has been in program knows that they're the first budget that everybody goes after because they're that current year budget. So that was the background which I was given to start this program. After looking at that and looking at what the politics are behind the program, I started to look back to when I was the deputy for systems engineering, and the Navy was going through some very hard times. First of all, they had terminated the A-12 program, which was to be the replacement for the A-6. It was a stealth carrier-based aircraft. That termination was caused by an inappropriate termination of a contract, which led to years and years of protests by the leading contractor. And as such, every year the program was continued to be protest. The funding required to pay them off went up by almost $1 billion a year, and that was to come out of current year program funds. Additionally, when the A-12 got canceled, the Navy immediately went through, okay, we need to replace the A-6. So they looked at a trade-off between the F-14B and F-18 EF as an alternative for the A-6. That program caused major problems between several of the major contractors in aerospace. Also, at the same time, the Navy was involved in the P3 Update 4 program for bringing the P3s up to a new level of capability. Also, the S3 was in its sunset mode and was looking for other options to keep it productive. V-22 program was also intact at that point in time and was fraught with numerous technical problems that continue even to this day. The reason I bring this all up is that the Navy was going through a very hard time of coming up with budgets to do a whole bunch of things. So when I looked at what we needed to do to bring our E2 program up to date, I had to look at that from a perspective of the politics that were going on with the other programs and who was going to be available to try and help us do something that would make sense as opposed to trying to execute the program I was given. So with that in mind, Captain Dale Babin and myself, Dale, who was at that time head of advanced development, looked at various things that would need to be done to keep the E2 program viable throughout what we estimated would be the threats out to 2050. So we then looked at a milestone chart that would lay out all these different things that would be required. Meanwhile, we were getting inundated by various alternative programs, which included the S3 in various shapes and forms, from a diamond wing to a Dorito chip electronically scanned antenna, to an ESA array, to a roll-on, roll-off capability that would involve ASW, ECM, AEW, and tanking, all those missions on the same platform. And the contractors and the proponents were saying this can be done on board ship in a matter of 3 hours. You can change out the package and make it do whatever you want. Well, anybody who's ever looked at that kind of evolution understands that that is almost nonsense. Where do you store all the other stuff on the carrier? How do you do it on a carrier? Where do you do it on a carrier? Et cetera, et cetera. So we had to go through various methodology to dispute what they were trying to purport was true. Their idea was that it was very cost effective. When we looked at it from analysis, it would cost more than it would cost to do a new airplane from scratch. Also, we were fighting the P3 AEW group, who wanted to make P3s land-based. Along with that was the E3B airborne early warning program, which also wanted to make everything land-based. So the first question that we had to go forward and ask is, okay, what is the Navy's position? Do you want to be airborne as a fundamental concept on carrier, or do you want to face all the issues of land basing, airspace management, et cetera, to do this from the land? And the Navy came back and said, no, we're going to keep AEW on the ship with the air wing. So from that point on, we then started to do what we really wanted to do was keep the E-2 airframe as the viable entity and put together all these other elements to make it viable as a complete and capable platform for all the missions that it needs to address within the air wing. So we then went to a production decision, but the production decision came about as a result of being able to work with N86, who was then purporting the CEC program. And the results of the discussions that we had with them turned out that we were able to use money from them to do some of the upgrades. But before we got to that, we had to go back and once again look at, okay, if I had to execute the program I was given to execute, what would be the outcome of that? Well, the outcome of that was that all the airframes, the group zeros and group ones, after you did all the upgrades and everything, would only wind up with somewhere between 3,000 and 5,000 hours of life. And if you wanted to make them equivalent to a new production aircraft, you would have to go through various replacements. And those included, two airframe replacements, 3 outer wing panel replacements, 2 rotordome replacements, 3 horizontal and vertical stabilizer replacements, 2 landing gear and resting gear replacements, and 4 to 6 propeller replacements. Well, when you added all that money up, it came to basically the cost of doing a production aircraft. So we went through all those discussions with the ASN RDA and the Secretary of the Navy, and we came out with the decision memorandum that I'll talk about later on in the program. But early on in my time as the PMA, even before I actually physically took over, I attended two very important briefings. One was by Dr. Tom Apries at NRL, and that more or less set the tone for what we were going to do, because he was the first to show us the capability of doing twice the power output that we had of the current, which gave us a much greater in-depth capability of seeing targets in a wider spectrum. The second one was also was not at NRL, but was at MIT Lincoln Labs, and that was a briefing by the Air Force on one of their programs. Suffice to say, we won't go into that anymore. So as a result of that, Captain Jerry Pike, who attended that briefing with Dr. Apries, was head of N89 advanced programs. And after discussion with him, he came up with $1.5 million R&D funding to begin the program. Well, the program really started with things that had occurred before. And I will, before I go back into the vision development, I'm going to turn it over to Jim Day to talk about those things that were occurring prior to 1992. Jim?
Thanks, Pete. Jim Day, I'm retired from Lockheed Martin. And before Lockheed Martin, it was GE Aerospace. late 1980s, we were looking at the end of the production of the EPS-145 radar that goes into the Group 2 E-2Cs and trying to understand what we needed to do to the system to enable growth and capabilities going forward. And the key driving requirements included increased sensitivity, ability to detect smaller targets, and to extend the blue water mission into overland and littoral regions. That drove us to a set of technologies that we started investing within our research and development dollars to develop that technology. The key technologies we were looking at were working with Grumman and Bob Higgins from Grumman and from Rantron, who was the supplier of the Track A antenna that went into the Group 2 aircraft, and looking at the antenna and radar functionality that needed to be developed to be able to meet these goals. So critical elements of that were that we needed a distributed solid state transmitter that could increase the sensitivity of the system. We needed an antenna that could electronically scan and rotate. So that led to the development of what's called the ADS-18 antenna and an 18-channel rotary coupler. We also needed digital receivers to handle all 18 elements of the array and adaptive processing, labeled space-time adaptive processing, to handle the clutter from ground clutter from the overland environment and jamming, both casual and intentional interference. So what we did is we started that development and put together a demonstration of space-time adaptive processing with what we called the Velcro antenna. It was a version of the ADS-18 antenna that had lots of flexibility. They could move the directors around to optimize the performance. And we were able to show that in a ground demonstration, the advantages of space-time adaptive processing, and that helped lead to carrying forward with Tom Apriest's presentation and some funding from the advanced development side of the Navy.
Hey, thanks, Jim. I'll go into what happened then, taking what Jim and they and the other contractors did to help give us the progress that we needed. We began to write this vision briefing, and the first thing that we will discuss, I'll let Jim and go through this again very quickly. The first things that we wanted to do were the RMP program, the 18-channel rotary coupler, and the advanced development with the ADS-18 and the STAP. So I'll let you really quick summarize that, and then we'll get on with the rest of the briefing.
Fred, why don't you go take that on?
Okay, Jim. Yeah, this is Fred Lee. I was at the Naval Research Lab in that time frame, working for Tom Apriest on the exploratory development part of the program. And we were providing some of the seed funding specifically for the Velcro antenna that Jim mentioned. We were working with DARPA on what was called the Joint Space-Time Adaptive Processing Technology Development Effort, and really just trying to drive various different critical technology items that were needed to realize the RMP. And I guess Peter, you're going to go into the mountaintop, because we used the mountaintop program really as the focus for bringing those technologies together.
We'll get into the mountaintop a little later after we go through a few iterations of other stuff, and then we'll get back to the mountaintop and where that led us to from there.
Fantastic. Well, that was the result. I mean, the 6.2 project, I think, was successful. It led to the briefings that showed the promise of the technology and the fact that it was feasible for this to be implemented.
Jim Day back here. I wanted to emphasize that one of the things that was critical was the collaboration. So we We had people from GE Aerospace, we had people from Rantron, we had people from Grumman, we had NRL, we had MIT Lincoln Labs, and the PMA all involved in looking at these studies and trying to understand what the right solutions going forward. And it was it kind of enabled some other space-time adaptive processing efforts going on at Lincoln Labs, not just for the carrier-based AEW, but all other programs as well. So I thought it was kind of unique in the amount of collaboration we got. It was very collegial, and we were all really looking to solve this problem, for the future of the AEW mission. Thanks.
Thanks, Jim. Fred. Okay, what I'm going to do through now are the elements that we put together for the vision, and I will go through a bunch of them. But then I'll turn it over to Jim, and he will, Jim Clifton, and he will, in a subset, go through these various things. It's important for everybody to understand the depth at which we went through these and what we felt, all the things that were necessary. Now, Jim won't cover every one of them because some of them won't actually take place until later after the SD&D program is in actually was underway. So the first thing that we looked, besides what Jim and Fred covered about the radar, was an identification friend or foe improvement. We won't get into any discussion other than to say it was on the list. An advanced ESM system, electronic surveillance measurement system, that we needed to be able to add elements to that, both high and low bands. An L304 replacement, which is the Litton 304 computer, and that became a commercial off-the-shelf mission computer upgrade, or MCU. Advanced control indicator system to go with that, which was also a commercial off-the-shelf glass, pardon me, glass display. We needed, because of the criticality of the radar, to improve our navigation system from what we currently had, which was the inertial navigation system with heading attitude reference systems and the air data computer, and replace that with a dual global positioning system with a backup for the inertial navigation system. And then we looked at a communications upgrade, which included satellite communications up, so we could use this from well over the horizon as opposed to be tied to the carrier in line of sight. Cooperative engagement capability became critical to this, because once we started looking at the amount of information that we were going to gain through all the upgrades and through particularly the radar modernization program, it became very obvious that there were no connectivity spigots big enough to handle the data that we needed. So adding cooperative engagement would lessen that, not completely get rid of that requirement, as did the Joint Information Distribution System. Additionally, when you looked at all the data that we were going to be collecting, we started under the mission computer just to look at artificial intelligence and how that would play in making the decision trees easier to handle and be able to provide the information for to get down to the decision makers on the ground by doing the sorting, or most of the sorting, in the platform itself. And then once we looked at that, we said, okay, but one of the things that probably we'll need to do is incorporate a glass cockpit, which will give us 2 additional operators and make us a 5 operator at any given time, or 4 operators if you wanted one person up front to always be in the flight control mode. Eventually, we had to look at in-flight refueling, because the criticality of the missions which we were going to become involved in, range, time on station, safety, and recovery all became issues associated with why we needed to have in-flight refueling. That led us to how do we get more increased time on station, et cetera. That looked at the T56 427 Alpha engine upgrade and propeller replacement. Those would all require upgrade generators, upgraded vapor cycle, and those were things that would actually occur later on in SD and D for the airplane. And finally, the one that never got involved, never got incorporated, but was always there because it became one of the big issues, and that was the surveillance infrared search and track, or CIRST. And that would allow us to do a better job of identifying non-cooperative targets in any environment, either over land, over water. So with that, I'll turn it over to Jim Clifton, and he can walk through those that he was involved in and show how those were coordinated with CEC and several other funding issues. Jim?
Hi, this is Jim Clifton. I'm a retired Navy guy and worked for the government afterwards. Retired from the government also. What I'm going to say is a little duplicative to what Pete outlined, but what I want to do is emphasize the complexity of what it took to bring all of that together into an aircraft configuration, and hopefully I can make that point. This Hawkeye 2000 actually began from the outside looking in as a seemingly disjointed collection of various engineering change proposals with a whole bunch of different advocates and sponsors, all of them, every one of the elements unique, and with different budgets and different schedules. Luckily, we had some expert program managers through the years. Captain Shepard was one, Casey Barr, and Captain Lilly, that were able to manage the expectations of all those advocates and sponsors, and shape it all into a coherent program that satisfied those players, but simultaneously set us up for a more drastic leap, which was to move from the Hawkeye 2000 to the advanced Hawkeye. So with the Hawkeye 2000, there were a lot of elements to it. I'm not going to cover them all, just some of the more interesting ones for this forum. There were about 10 or so that I'm going to talk about. Pete mentioned CEC. The CEC community very quickly realized that they couldn't advance their vision without an airborne node. They also understood that the future radar that we were working on would do a lot to enriching the CEC fusion problem. And so they became great advocates for all the things that we were trying to do at the time. From our perspective, we recognized that the CEC advanced our network-centric warfare vision by providing us with a much enriched, much more robust source for off-board data. Probably the major change, the most major change that came with Hawkeye 2000 was the mission computer upgrade, the MCU. And it came with its own advocacy, mostly because of the archaic nature of the L304. But the CEC program managers, they understood that we had to have that computer in order to get the CEC in the airplane. So once again, they were great supporters. They also were supporters not just of replacing the computer, but changing the architecture in the airplane, which was the most, in my mind, the most important element of the MCU program. They understood that we needed to do that for the advanced Hawkeye radar, and as I mentioned, they were great advocates for that radar. The relationship with CEC, it further got strengthened by the selection of the display that we used with the MCU, the Q70. And some people may not know that display was actually a derivative of the shipboard CEC console. These changes, as I mentioned, this is in my mind the most critical and important thing that was implemented in Hawkeye 2000, and they were crucial to the advanced Hawkeye, particularly the architecture change, and also that it traded a mission computer, the L304, that relied on 16K memory modules as an example, and by K I mean kilobytes, to give you a sense of how archaic it really was, and also relied on its own computer language, unique to that computer, and only a handful of people could actually program it. Pete also mentioned the avionics cooling system. It had a story. It actually started as a statutory requirement based on the Montreal protocols, and also to fix some obsolescence issues. But we were able to leverage that upgrade to get the increased capacity necessary to support CEC and the other systems, and it became the baseline from which the advanced Hawkeye's cooling system was spiraled out. There were a lot of communication system upgrades that were made. The largest in terms of new capability was probably the full integration of satellite voice and data capabilities. They were largely abdicated on the basis of more capability and increased reliability, but as a program, we always kept an eye on the future for those comm upgrades, and we're adding more capability we knew we'd need down the line. And as a former class desk, one of the most important features in my mind was the weight and volume that it produced that was later gobbled up by the advanced Hawkeye. The new ESM system had a very interesting start. It was made possible because of the multi-year procurement that Captain Shepard was able to get started for us. The legacy ALR 73 was horrifically expensive, so much so that it turns out we were able to procure the replacement system, the LQ-17, with significantly more capability, with enough money left over to do the bulk of the non-recurring to integrate the LQ-17 into the airplane. Again, as a former class desk, one of the important features also was the reduced weight and volume that came with the new LQ-217. The 8-bladed prop, it also had an interesting start. The manufacturer of the propeller notified us that they were no longer going to produce it. It wasn't too long after that we had a step increase in failures on the propellers caused by delaminations in the blades, and kind of put us in a hard spot. Luckily, the logistics community stepped up and funded a logistics engineering change proposal, an LACP, that paid for the non-recurring to move us on to a new propeller. It ended up as an 8-blade propeller instead of the 6-blade configurations that was common for the T-56 at the time, the most recent T-56s at the time, because based on analysis and significant testing that we had done, we determined that an 8-bladed prop, as mounted on an E-2, would reduce the vibrations in the airplane by about half, and what was left was largely constrained to the 8P frequency and its first harmonic, which we had a good understanding of in terms of its impact on the avionics. That was very important as we moved into modern avionics. The components were smaller, and vibration was becoming more and more crucial to reliability, and it was important to Hawkeye 2000, even more important to the advanced Hawkeye. The navigation system upgrades solved some critical supply and reliability issues and provided increased accuracies. But one thing I want to note on this is it was the first element that was funded of the Hawkeye 2000. So it was the first one, had the first schedule, the earliest schedule, and was the first to come to be enacted. Given this new computer architecture, the new navigation system at CEC, it was becoming painfully obvious that we were going to have to move and have a paradigm shift in the way we did pre-mission planning. We enacted a considerable effort to shift from paper-based pre-mission planning into computer-based with mobile medium that satisfied all those pre-mission planning needs and was able to make alert launch time constraints. This was significant for Hawkeye 2000, but I can't imagine we could have moved on to the advanced Hawkeye without having made that step. And again, it was a major architectural move, so it was very important. Also running in parallel, I'm sorry, let's talk about in-flight refueling first. in-flight refueling started as a groundswell from the fleet, and it while it wasn't necessarily tied to the Hawkeye 2000 program, it ran in parallel with the Hawkeye 2000, and initially started as a demonstration that was a Israeli system that we installed on an airplane at Pax River. Also running in parallel with the Hawkeye 2000 were efforts to produce a modern tactical cockpit. Pete mentioned these. Demonstrations were done, some prototypes were developed, and that became the basis from which the glass cockpit that was advanced in the advanced Hawkeye ENMD and the fourth and fifth operator functionality became the basis upon which that was developed. I think during the Hawkeye 2000 days, it became obvious to us that the fourth operator was critical. And while I didn't spend much time in the advanced Hawkeye, I understand that it's absolutely critical in that airplane. So sort of to summarize where some of this went, if we'd enacted all those Hawkeye 2000 efforts as they came about on their own naturally through the requirements process. Remembering back to the days, we weren't able to come up with a plan that produced two squadrons of the same configuration over the life of what would have ultimately been those programs. By massaging those and putting them into one configuration, which became the Hawkeye 2000, we did have to slow some things down. For example, the nav upgrade kits were slowed. Several of those got moved to the right. But ultimately, we ended up with a much more efficient program. And in the end, the airplane was a more fleet-ready aircraft, and it definitely prepared us to get ready for the advanced Hawkeye and move on to the next stage. While the Hawkeye 2000 was maturing, there were a number of initiatives that were started both inside and outside the government. Pete mentioned a few of them, to acquire a multi-mission platform to produce and I'll put this in air quotes, the support missions for the carrier battle group. There was a long shopping list. Pete mentioned some of them, of carrier-based aircraft, land-based aircraft, unmanned, and some space. The range of missions included the AEW, Command and Control, ASW, ELINT, Comment, tanking, and emergent missions like theater ballistic missile defense and ground target surveillance. I'll mention one that I don't think Pete did. The common support aircraft was a note. It took a lot of time out of the program when it was being done. It was an N88 initiative, but ultimately it was determined that the range of missions and the resulting requirements were so broad that there was no way that it was going to be possible to meet all of them with one system, at least not with any reasonable, and I would extend that to say even a Herculean budget and very long time frame. Ultimately, it was acknowledged that it was going to be multiple systems to meet those missions, and the E-2 would carry the airborne early warning command control missions into the future. One fallout of the multi-mission discussions was that during that period, we spent a lot of time looking at adding new missions to the E-2 airframe. Not all of those missions that I listed at the same time, but individual ones on an airframe based on the E-2. And in a few cases, it would have been legacy E-2s that still had hours on them being gutted and used to perform those missions. For example, we looked at the tanking mission. We did preliminary designs against that configuration, multiple designs, but and while it looked like it could perform the yo-yo tanking job, our center of gravity precluded us from moving enough fuel forward in the airplane to be able to perform the full mission. We did preliminary designs against ELINT and Comet. Ultimately, and they were very promising, but ultimately it was determined that those missions were going to be moved to land-based aircraft and unmanned platforms. One mission that, and Pete mentioned this, one mission that started gaining traction was theater ballistic missile operations using infrared search and track it's fused in a C-like fashion to produce very long range and highly accurate detection and tracking in support of the Aegis cruiser for theater ballistic missile defense. We actually performed 2 demonstrations of those systems that proved the technology was capable of doing the job, but ultimately it just sort of fizzled. All of this activity that I've mentioned, the Hawkeye 2000 and all these other projects and studies that were performed happened concurrently with the advanced Hawkeye radar S&T activity, the planning for the advanced Hawkeye program, and the initial advanced Hawkeye contractual actions. And a point I'd like to make is that it was just, as I recall, a very, very busy time, 5 or 6 years inside the program office. And with that, I'll pass it back over to Pete.
The only thing I wanted to make a point of is Jim brings up all these issues, but Jim and the program were going through this development of all these different capabilities that we wanted to incorporate into the airplane. At the same time, we're trying to fight off all the political issues of all the other people who wanted to take over our mission and do all those things. So I want to make sure everybody understands the depth and length to which we had to go to get the program going, protect the program, and fight off all the naysayers of this program. And it wasn't only during my time frame, but every PMA after me has gone through the same issues over and over again. So it took a lot of effort and a lot of ability to have guys like Jim and Jim Clifton, Jim Day, Fred Lee, who always went to our briefings with us and could overwhelm the people with technical issues to show them why they didn't know what they're talking about. So with that as a summary, what happened then in 1993 was the Secretary of Navy, ASN RDA, Nora Slatkin, was getting beat up by congressional staffers and everybody because everybody thought that we should be looking at commercial off-the-shelf technology for replacements. Well, nobody had put out a directive like that. So she put out a call for commercial off-the-shelf technology. So we sat down with Clifton and said, okay, why don't we make the mission computer commercial off the shelf instead of spec Navy specs? And so I think it took him like 2 weeks or 3 weeks to rewrite that whole thing. And we raised our hand and said, we can give you something. So we actually got a what would actually be a milestone decision, which we didn't think it was going to turn out that way, but it actually did, with ASN RDA, and went and briefed the mission computer upgrade along with CEC and the ASIS display, which was also commercial off-the-shelf technology. And not only did she like that, but she approved our milestone decision for going ahead with that, as well as our milestone decision for going back into production of the Group 2s, which then allowed N88 to reprogram our $1.7 billion budget into a budget that allowed us to be in production in 1994 with 2 Group 2s, along with 4 Taiwanese Group 2s, and allowed us to move the production and restart it down in St. Augustine. And that was the major milestone decision that allowed us to go forward with the upgrades that Jim talked about and with the program overall. So the milestone decision was very specific in that it said, 1, we will continue to do continued production of E2. We'll use the E2 airframe for all future upgrades. They approved the MCU ASIS and CEC programs. And finally, it said that the E2 will serve as information integration and weapon system delivery aircraft central to defending fleet from air and missile threats. That was all in the milestone decision. So that milestone decision allowed the program to basically get rid of the old budget and process and reprogram everything so we could actually go do some of this stuff. And then as a result of that, Admiral Remp actually funded the, as Jim said, CEC MCU ASIS upgrade, and that allowed us to continue. And once we had that decision, a lot of the alternative things, while they continued at a lower level, some would pop up later on in the program, but they were tamped down for a while till we actually were able to get going with that. And then finally, from 1994 to 1998, we had various demonstrations, some that were funded by N89 and some that were funded in combination with the contractors. But I'm going to turn that over to Jim Day to talk about White Sands, Coquet, and the Mountaintop. And then I'll turn the last part over to Jim to talk about the airborne C-130.
We had done some lab demonstrations and ground-based demonstrations of space-time adaptive processing, but there were still some naysayers out there, and so it became clear that to make the project successful and get us into an advanced Hawkeye development program, we were going to have to prove those naysayers wrong. So one of the first steps along that way was that the Navy funded an effort where Lincoln Labs married up an ADS antenna with a Rister radar. Rister was a radar that Lincoln Labs already had in place, so that they could go and prove that the ADS 18 antenna could be electronically steered. It's an antenna that fits within the existing E2 dome's volume, but it has Yagi directors forward of the backplane like the Track A antenna, but it was with 18 elements at half lambda spacing so that you could electronically steer. But there were folks with lots of high reputation folks that didn't think you could electronically steer a Yagi director antenna. So they purchased this antenna, married it up with Rister, took it out to White Sands, and demonstrated that you could electronically scan. And that was kind of the first step, but we also needed to marry that up with versions of the system that were similar to what could fit into an E2. So that led to demonstrations at a couple different sites in Hawaii. There was a demonstration on the Coquet site, and then in Makaha Ridge in 1997, we had real-time space-time adaptive processing married up with the ADS 18 antenna and rotary coupler, and showed that we could do that, the receive chain processing of that system. And that was critical, an additional step to proving that the system was viable. So the antenna and rotary coupler were in the same kind of configuration from a volume and weight perspective as you would see on the actual E2, and we were trying to get the receive processing to marry up with what would fit into the aircraft. Then in 1999, leading up to 99, we needed to build up a transmitter, an exciter, and to marry it up with that system. That took some significant development effort. There were some challenges with the power density we were trying to achieve, combiners and other individual components were stressed. And we were eventually successful with that, and were able to demonstrate in the summer of 1999 the radar system on the ground. So those were kind of the major ground demonstrations. They were critical to keeping the interest level in the program and for actually selling the program.
Thanks, Jim. Now, just because we were successful at those sites and successful in demonstrating it, the last critical element of that was we needed to for all the real naysayers, they said, well, you got to demonstrate this airborne. So Clifton, who was my guy who went out and stole airplanes, went back to the Air Force and got the C-130 back so we could do an airborne demonstration. And I'll turn that over to Jim to talk about.
Okay, so probably the first question was why didn't we use a P3? At the time, there were half dozen or so P3s that had E2 domes on top of them, and including a test bed that was being produced by the CEC program. The other P3s were used by the Coast Guard for counter narcotics work for the most part. The reason we didn't was the saddle structure was built in such a way that the dome couldn't be elevated high enough to accommodate the rotary coupler for the ADS 18, the 18-channel rotary coupler. It would only accommodate the legacy rotary coupler, so it just plain wouldn't fit. Luckily for us, though, there was the C-130. It had started as a Coast Guard program many years before. They were going to do fisheries surveillance up in Alaska. They built it. And we knew about it because it was first because of the Grumman involvement, but also because it was tested at Pax River. But just about the time they were getting ready to field it, they didn't have much time flying in Alaska. The Commandant of the Coast Guard decided that he wanted to reduce type model series count in the Coast Guard. And since that was a unique airplane, he struck that from their inventory. Edwards took the airplane then, and it was used for a number of years as a test bed for mounting avionics. And they kept custody of it for a number of years. We went and talked to them at a fortunate time. It was late in the budget year, and we were trying to figure out how to do some maintenance on the engines, and we were willing to take the airplane from them and take it back into Navy custody at Pax River. So ultimately, they released it to us. It had fortuitously also it had more capability in terms of weight and volume than the P3 would have had in that configuration. And we were able to do a lot more with lavish type equipment and lavish type racks in the C-130 than we ever would have been able to do with the P3, partly because we just wouldn't have to move it through a door. We were able to do things like use true lab equipment, and instead of fully developing it for an aircraft environment, we were able to cage it. So the cage, for example, was able to handle the G-load crash requirements for the avionics mounted in the airplane. At any rate, it turned out to be a great choice for us. It provided what we needed to be able to mount the early radar without having to be way down the line in development of either the radar or the aircraft configuration. And while that majority of the installation and all the testing happened after my time, I understand it worked like gangbusters and did the job for us.
Just a couple of points about the C-130 demo is that I thought it would be good to mention that probably what tipped the scales was some systems of systems demonstrations. And I'm not sure how far we could go with that statement, but I thought that was really what tipped the scale. From an engineering perspective, we really needed to get airborne radar data to be able to feed into the SD&D program. That airborne radar data was critical for us to be able to understand the requirements for the adaptive processing and the transmitter stability and a bunch of other things that from an engineering perspective was critical. So I mean, we didn't really mention that, but from my perspective, that was technology wise significantly more relevant data than the ground-based data. The airborne data was just really critical.
That was actually the last and final step that allowed us to actually get to a SD&D program, was that airborne demonstration. That was critical. I've failed to mention him before, but one person who was critical through this, who worked very closely with Fred Lee and worked closely with Jim, was Skip Sheed, and he was instrumental in getting a lot of stuff done. And it's I don't know that we would have gone a lot of places without his input and his constant monitoring of the program. But following the airborne demonstration, basically we had completed kind of the vision of what we wanted to do to get to a E-2D or advanced Hawkeye, or whatever you want to call it today. And it wouldn't have been at all possible without the investments, the time, the engineering efforts, the intelligence of all these people that you've been talking to today, as well as a whole host of others, which we'll put in the whatever you want to call it, the appendix, for people who actually need to be recognized for this program. Lee?
Okay, thanks a lot, Pete. To summarize, it took extraordinary like-minded individuals and efforts over several PMA 231 program managers, commodores, various contractors, government entities, and agencies, the E-2 fleet, the suppression of continual outside political influences, and continual budgetary attacks to adhere and achieve the vision of the E-2D advanced Hawkeye that has become so critical in the Navy today. While you've heard from several key players in this discussion, it goes without saying that it took a large team of like-minded individuals over 30 continuous years to provide the results seen in the Navy today. I would like to recognize a few of those individuals in the personal appendix and the organizations to which they belong. The Foundation thanks Pete Shepard, Jim Day, Jim Clifton, and Fred Lee for sharing their experience, and thank you for your dedication and service to our nation.